Hello, our telecom engineers friends. This is our first English course, and we will start by ASON. First of all, ASON is a technology used to manage the traffic and add protection and restoration over traditional transport network like SDH and DWDM. Unfortunately, the MPLS or multiple label switching protocol essentially used for IP network to manage routing over statistical multiplexing, not TDM. That's why ASON is introduced to manage the TDM network or transport network by modifying the MPLS protocol to be matched or to be compatible with TDM network like SDH and DWDM or OTN, modifying the MPLS to be GMPLS or Generalized Multi-Protocol Label Switching. During this course, we will highlight these items including ASON hierarchy, generalized multi-protocol label switching, optical signaling protocol like RSVP or resource reservation protocol, routing protocol like OSPF-TE, link management protocol, network management protocols like SMP, Netcon, and Corba, and so on. Software permanent connection, including permanent connection and switched connection, ASON domain, and how to insert and add nodes and links to the ASON domain, protection and restoration difference between ASON for two main vendors, including Nokia and including Huawei. We will find them same, of course, but some acronyms or some protection or routing naming may be changed from one vendor to another vendor, but the function will be same. Implementation in optical network. What is the steps to implement ASON over optical network? We will include here DWDM network and OTN network, but we will not focus on SDH as SDH regarded as a legacy technology not covered by this course. Real-world scenarios. These scenarios will be added to show how practically we can use, utilize, and exploit the ASON according to its features and according the different configuration shown in its SLA and quality of service. First, we should mention the traditional protection schemes. As we know, we have different protection schemes implemented firstly over SDH networks. Most of these connections supporting two paths like SNCP or 1+1 MSP or MSP ring. In some situations, they are naming MSP ring as BSHR or bi-directional self-healing ring. The BSHR implemented in this network or MSP ring, 50% of traffic is going to the west and 50% of the traffic going to the east. When we have a cable cut, we have ring protection. The 50% will go over the extra traffic on the east direction. For 1+1 MSP ring, we have traffic going over the main link and traffic maybe go over the backup link in 1+1 or not going on the backup link in 1-to-1 when a failure occurred in one of fiber or two of fibers according to the configuration, single-ended or dual-ended. For SNCP doesn't need APS or automatic protection switch like 1+1 MSP or like MSP ring. Just it requires a protection over each service and protected from end to end and the protection added per service. But for all of them, we have just only two routes to bypass the traffic, main and backup. If the main go down, the traffic will be directed over the backup path. If the traffic restored or the main path restored, it will go back to the main path or not going back to the main path according to the configuration, revertive or non-revertive. So we have fixed function and has a limitation. Switching reliability within 50 milliseconds This is very good here because we are working according to the standard. So it is reliable in switching, but not reliable to handle more than one protection path or working on different topologies like mesh topology. ASON and GMPLS. ASON is regarded as a framework and technology. Framework because it is providing us the hierarchy of protection and a system hierarchy. Technology because it is doing routing and signaling for the service, the function of protection or the function of rerouting the impacted service over new route. ASON is more intelligent, exploiting the GMPLS, so it has the capability of routing over multiple paths like packet network or IPM PLS networks. That's why it is more intelligent than the previous traditional protection schemes. It can do multiple routing, multiple switching to different directions over multiple layers of services, including optical services like OCH and electrical services like ODUs. The GMPLS itself is a generalized multi-protocol label switching. It is a customized protocol to manage transport DWDM traffic and reroute the traffic in case of failure of any of the network routes, including network topology convergence and maintaining the link and manage the bandwidth through the network. The GMPLS itself, it is a kind of software installed on the control plane. The control plane, according to the ASON, we have 3 planes we will show in the next slide. So we can see here GMPLS or generalized multi-protocol label switching. It is just a software installed on the controller of the transport network nodes or transport network elements to handle the functionality of ASON. Why ASON? ASON is a flexible protection as introduced before against multiple cut and automatic restoration in case of multiple failures. We can assign different SLAs and quality of service as we have a traffic engineer links. These virtual links created between two neighbors to represent the bandwidth and the status of the link between the nodes. It can be multiple TE links between two nodes, reroute the traffic over the network through the TE link, or creating the NSP and call through our mesh network. The good thing here, you shouldn't care about the network topology. You can create the service from end to end through management plane. The management plane here is the NMS or the application provided by the vendor to manage his network. Better bandwidth exploitation, important feature in ASON. As for BSHR, for example, we are hosting 50% of the traffic in east and west to maintain protection in case of failure. For 1+1, we are hosting 100% of resources and not utilized even for high quality of service requirement or no quality of service requirement. So we don't have quality of service, cannot differentiate between the different traffic and different customers and reutilize the residual resources for another customers. Real-time network management and discovery in case of expansion of the network. ASON through the OSPF protocol will detect the change in the network and modify the routing table inside all controllers to create and handle new traffic engineer links between the different nodes. After that, the operator can create the service from end to end through the NMS. No need assign or define the new topology like BSHR or MSP ring. Just add the new node to the ASON domain after assigning the unique ID to this node or to this new element. After fault rectification, the traffic will be restored automatically according to your configuration, to be revertive or non-revertive according to the customer requirements. ASON hierarchy. In traditional hierarchy, we have just only two planes, the management plane and transport plane. There is no any kind of control plane, and according to the protection scheme, we can protect our service from end to end mostly over two paths. But for ASON, we have a control plane as in earlier slide. In control domain, we have our GMPLS protocol installed on these nodes to handle multiple options and multiple functions like network convergence, creation of service from end to end, routing for the affected or impacted services, maintaining the TE link between the node, managing the control channel. Thank you for watching that today. Next time we will continue in introducing the remaining part until reaching to the advanced configuration for the ASON technology.